Greetings everyone, my name is Jimmy Linville and I'm the owner of 4L Irrigation. I've got several videos out there. I got one about controllers and seeing if it's working electrically. I've got one about how to find valves in your yard. I've got one about how to find shorts on the wiring in your valves. I got some general overall instructive type of videos. But today in this video we're only going to talk about field wiring. So we're talking about the wiring that comes from your controller and it goes out to each of the valves in your yard. And we're going to make the assumption, number one, you know where all the valves are in your yard. And number two, we're going to make the assumption that everything is working correctly with the controller. And so we're not going to check those things and we're going to walk right to the valves because we know exactly where they're at. First of all, I'm going to talk to you about the setup just a little bit. Everyone has a meter at their house, and that's how the city knows how much to charge you for your water. Or if you're out in a rural setting, you have a well, you have some sort of source that it is coming off of. And that water is going all the way to your house. This dollhouse of my granddaughter's is representing the house that it's running to. And in between that meter or that source and the house, the irrigation line is going to tee off. If you have a new irrigation system or a newer one, you'll have a ball valve in between the backflow device. This is a double check backflow device so that you can turn it off if you need to work on that. Some older systems will have one after the backflow because they've just added that so that they didn't have to use the backflow to turn the water on and off. And some may not have it at all. And then you're going to have a backflow device, and all houses, regardless if it's a well or whatever the situation, should have a backflow device. We're in North Texas, and most of the houses here in North Texas have a double check backflow, and this is what a double check is and what it looks like. We can cut off, by just turning one of these handles, we can cut off the water from here back. And so none of this would have water if we turn these off. And then some systems have a master valve and some of them don't. Again, if you have a newer system, you're required by law to have a master valve. And what happens is the water comes from your source, it goes through the ball valve, it goes through your double check backflow, and right now it stops at this master valve. And then, and it's a safety mechanism is all it is. That way, if one of these valves go bad in your yard, the water is only going to go out of it as long as the controller's running, because when the controller shuts off, the water is going to be stopped at this master valve. So when you say turn on zone 1, the controller gives AC to this master valve, and it turns the master valve on first, and then it turns on zone 1. And that happens the same with each and every one of your valves. To run a valve, you only need 2 wires. And so in this scenario, we have 5 valves. We have 4 out in our yard, and we have the master valve. So we need 2 wires for each of those. They all share a common wire. So in this scenario, we have 5 valves. So we should see 5 direct wires and 1 common wire that they all share. And this is to help us. We only have 5 valves here, but imagine if we had 30. And each of those had 2 dedicated wires. We would have 60 wires coming up into our station. So this saves us time and space. You don't have to splice all the commons together. This is how almost all systems are set up. Keep in mind, this common is shared. So if something happens to this common, for instance, if we were to cut the common right here, and this cut is before all the valves start, then we wouldn't get resistance on any of the valves. However, if we were to just cut one of these direct lines, we're only going to impact that valve. So that's very important when you're troubleshooting. Keep that in mind. So we're going to start off, and we're going to come up here at the controller, and we're going to take ohm readings to determine if our wiring is good in the field. And all AC sprinkler controller, residential 1-inch controllers, they're going to have an ohm reading, regardless of brand, of between 20 and 60 ohms. There is an exception out there now, and that's this Rainbird valve. And if you see, if I take the ohms on this Rainbird valve, you can see that that one is running 76. So if you have this valve in your yard, this is going to be the exception. You are going to have more than that. But all the rest of the valves, again, AC, Residential 1-inch valves, you're going to have that reading somewhere between 20 and 60. Before you start, I suggest you're going to have a multimeter, and it's going to have this omega signal on here. And this is going to help us to read ohms. And you want to get as simple as one as you can. And then you want to touch the probes together, and we hear that sound. That tells us that we have continuity. That tells us that our wires are working, that our controller is working, or our multimeter is working rather. So before we start looking at the controller, that's the first thing we want to do. All right, then we're going to come over and we're going to measure. And I've got these wires stripped so I can just put my probe on here and make it a little bit easier. And the first one is our master valve. Okay, so we get 0.6 on our master valve. We get less than 1 ohm, so we know that that's bad. That's representing some sort of short, and we'll go fix that in a little bit. Then I go to zone 1. We get nothing in zone 1, so that tells us that we have a wire that is totally disconnected. Zone 2. Zone 2 is 24 ohms, so that tells us that that one is good on zone 2. Zone 3 is nothing, so something's bad there. And zone 4 is nothing, something is bad there. So what we're going to do is the first thing, we're going to start with the master valve, because we know if the master valve doesn't work, nothing works. And if we come over to the master valve and we look at this, all of the connections inside your valve should have a water-resistant wire nut on it, something like this. Now it's water-resistant, it's not waterproof, this particular kind, but you don't need waterproof here, you just need water-resistant. Many times you'll look inside of a box and you'll see that the wires are actually touching each other. So this can't complete the circuit because they're touching, and I'm just simply going to separate these. Now, this could be between these wires. You know, if these wires had a place on it that was bare, if they touched, we would see the same exact type of thing happening. So while I'm out here in the field, I'm going to take the measurement on this one, and I'm going to put one probe on each of the wires, and you can see we've got 33 ohms, okay? So let's go back to our controller, and we're going to check, and we're going to see if our master valve is now good. So again, I'm going to put one probe on the common. I'm going to put one probe on the master valve. And you can see we've got 33 ohms. So again, if I get 33 ohms in the valve in the ground, I should get somewhere close to that. Not exactly, but somewhere close to that from the controller. So we have now fixed the master valve. So now we're going to go to 1. Remember when we did 1, we got nothing. We got 0 ohms. So again, in this scenario, if we look at this, we know this is, remember, we're pretending that we already know where all of our zones are. If I open up this valve box, and it would probably have a valve box like this, this looks a little different because it's going to drip, and it has a pressure regulator and a filter on it. But this valve is still the same exact thing as all the other ones. If we look in this box, we can see that one of the connections has come undone. Now, again, we said if we cut a wire, that just one of these direct wires and not the common. So if the common had been cut, we would have lost everything backwards. We would have had good ohms at the master valve, but everything after it. But this is not the common. This is just a disconnection of this direct line to zone 1. So I'm going to put these back together real quick. I'm not putting wire connectors. I'm just doing this simply to show you some of the numbers so that you can be familiar with what's happening. If I take a measurement on this out in the field, you can see that we have 40 something, I'm looking upside down, but 40 something ohms on there. So again, now I'm going to go back once again. I'm going to come back to the controller, and I'm going to put one probe on zone, or the common, and one on zone 1, and now we've got 41 ohms. So again, that should have been close to what we were seeing out in the field. If whatever it is out there, that's going to be very similar to what we see coming off the controller. So now we know that the master valve works. We've got that one, 33. Zone 1 works. We've got that up at 41. Zone 2, remember, already worked, so we don't have to do anything. But now we got zone 3 has nothing, and zone 4. So we're going to go back out to the field now. Anytime you have a series of valves that don't work, many times it is the common wire. And this is pretty simple, the way we have it set up. But what if this was on a 2-acre piece of property and these valves were 50 feet from each other and the controller was 150 feet over there, right? It becomes a little bit more complicated. On any of these scenarios, we could run 2 wires from here because we said it only takes 2 wires to get those to going, and we could run it all the way back to the controller, but that's a lot of work. So many times what I'll do, I know this one's working and everything towards the controller is working. So what I'll do is I'll see if it's a common wire. I'll simply take a piece of wire, and I'll do this on top of the ground, obviously, before I do any digging to see if this works. And I'm going to take this common wire and I'm going to hook it up to this one that I know is working. So I'm going to come in here, take that one off. And I know this common is good from this point back. So I'm going to hook these up. And I'm going to hook this one back up because it was working previously, we know. And then I'm going to come back and I'm going to take the new common wire that I have and I'm going to hook it up to this one. My direct one right now, and I'm checking to see, but I'm assuming it's working because I have a series of valves out. And I'm going to hook that up there. And then I'm going to come over here to this last one and I'm going to hook it up. All right. So now I have a new common wire going from the valves that did not work to the place that I knew the common worked. And we're going to come back over here and we're going to measure and we're going to see what we've got. Okay, so again, I'm going to put one probe on the common. And then I already know that the master valve is working. We got zone 1 working as well. Number 2 already worked and I hooked it back up and it's still. Remember 3 and 4 didn't work, so now I check number 3 and now it is working. I check number 4 and it's not working, okay? So that exercise proved to us that we did have a problem, and we had a problem with the common wire. So we just ran a new one. So now I just got to go back to number 4 and see what's going on in there. So when I come back to number 4, this is what again, I know number 3 is working. Everything else is working, so it's just this last valve. So the first thing I'm going to do is I'm going to take my wires off of this, and I am going to measure my resistance. Okay. So remember I said whatever we get in the field, if the wiring is good, we should get at the controller. And you can see this solenoid is bad. So that is our problem on this one. So I'm going to take a brand new solenoid and I'm going to put it on here. We're going to take this one off, the bad one. It just screws off. Whoops. All right, that one's off. And we're going to put on the new one. And we're going to take a measurement on this one again. We'd want to screw it all in, but again, we're just looking at the electrical aspect. Okay, so now I'm getting 23 ohms on this new one, okay? So now I'm going to hook it back up. I'm going to go back to my the good common that we had on top of the ground. And I'm going to put this direct one back on. Many times when you're doing this, you will see something that looks like this. So as you can see in this scenario, this was hooked up. See how these have been burned? So there's been some sort of electrical surge that has come into this common and burnt this up, and this is very common to see something like this. If you see something like this, many times you can say, okay, that's probably the scenario. And so right now we've got it hooked back up. Again, we said we had what? We had approximately 23 ohms. So now let's go back and look and see what we've got. So I'm going to jump over to that very last zone. And what do we have? We have our 23 ohms. So now, master valve, it was shorting out. It had less than an ohm. Now it's working. It has 33. Zone 1, it wasn't working at all. Now it's working. We got 41 ohms. Number 2, it's working all the time. It's got 24 ohms. That's what it did have. Number 3 now has 24 ohms. And number 4 now has 23 ohms. So everything is working correctly. So again, a scenario where if we know where everything's at, we can move pretty quickly through the process. And remember, it doesn't have to happen the way we have it happen here. We made those things happen, but it very well could be this wiring, and it could be right outside of the controller at your garage. It could be inside one of the boxes of your valves. I want to show you one more thing. People call a lot of times and they say, I think I have the right valve that I'm working at. So here is one thing, if you want to check and see if you've got the right valve or not, one way that you can check that. Again, if I come over here and I measure, and we're going to measure that number 2 now. Number 2 has 40, I'm sorry, that's number 1. Zone 1 has 41 ohms, okay? There's a couple of things that I can do to check it. If I come over here to zone 1, one of the ways that I can make sure that I'm working with it is there's a little bleed screw right here. And if I turn on the bleed screw to my master valve, because remember water is stopped back there, and I turn on this bleed screw and I see my drip coming out, and I know that my drip is zone 1, I now know that I have the right one. The other thing you can do is you can come in here, and again, remember, we're not going to cut this common wire, but if I cut this main wire and I go back, and I had just checked it, and remember we had 41 ohms. So now if I come over here and I check that zone 1, now we have nothing. So I know the wire that I cut was working, and now it's not working, so I can confirm that is zone 1. So that's a tip, because a lot of people, when they're trying to determine what zone in the yard, if that's really the valve that they're working on, that's what I suggest. Either cut the wire or turn it on manually. If you cut the wire, come back and check and make sure it's the one that you thought it was. If you turn it on manually and you know that's that zone, then both of those scenarios you have it